Assalamualaikum and hi everyone. We are from group 7 and today we will like to explain about linear phase system, which is the group delay is equal to time delay. So there are two delay signal, which is delay symmetry signal and delay anti-symmetry signal. And this is the graphic shows. This is the example of the delay symmetry signal and delay anti-symmetry signal. So to make sure the system is causal, the signal is delayed so that it will have non-zero value starts at n equal to 0. Thus, the causality problem in zero phase system is solved. For this system, of H omega equal to omega nd, and the phase delay and is equal to group delay and time delay. Is when the time delay is constant, so there will no have phase distortion. Okay, and linear phase system is valid for FIR system only.
Next is for linear phase system variation. There is 4 types for this linear phase system, which is type 1, type 2, type 3 and type 4. For type 1 and type 2, this is example for symmetry system, and type 3 and type 4 is for anti-symmetry system. For type 1, which is it is an odd system, which is 0, 1, 2, 3, 4. It will be mirrored at point 2. Okay, for type 2, which is an even system, it will be mirrored at point 1, between point 1 and point 2, which is here. And for type 3, for anti-symmetry system, it will be mirrored 180 degree, which is at point 2. And for type 4, an even system, which is it will be mirrored 180 degree between point 1 and point 2. That's all.
Okay, now we like to move on to example 2. Example 2, find H omega, find angle of H omega for system Hn equals to delta at n plus delta at n minus 4. Okay, firstly, when we have question, let's draw the signal at 0 and at minus 4 we have 1. This is the signal of Hn. We can see that this signal is a delayed symmetry signal. We can change this signal to a delayed signal of delta at n plus 2 plus delta at n minus 2. This is equal to the phase signal, because if we redraw it, it will be at n minus 2 and at n positive 2. It's just the same. It's just we delay it. Okay, so after we get the delay, we have to find the H delayed omega of the system. Therefore, H naught omega equals to H naught H naught 0 plus 2 n minus equals to 1 H n cos omega n. This is driven from the equation for the symmetry properties, where real and even signal, where x n equals to x minus n, from the symmetry properties. Okay, so getting back, calculating this and putting it in calculator, we will get h naught omega equals to 2 cos omega n. Sorry. So getting from the time shifting property, h omega is equals to time shifting exponential negative j omega n d times with h omega. So substituting our value into this equation, we get exponential negative j 2, which is nd, our time delay, omega, and our h omega is cos omega n. Okay, this then we expand. I'm sorry, ada dua sini. H omega is 2 cos omega n, and then we expand this part of the equation. So using the Euler, where exponential j2 omega is equals to cos omega plus sine omega, we substitute this to expand this. So expansion, we get 2 cos omega n here times with cos omega 2 omega, sorry, because here 2 omega, and then we minus, because we have negative j 2 omega, minus j 2 cos omega n sine 2 omega. Okay, first we know that from the equation, from the note before, the phase of h omega is equals to tangent 2 sine 2 omega times cos omega n over negative 2 cos 2 omega times cos omega n, where you just cancel that out, and then you get tangent negative, move that up, so we get 2 sine 2 omega over 2 cos 2 omega, where is equals to 2 omega. From the earlier characteristics of linear phase, the angle of h omega equals to omega nd, whereby this is true because our nd is equals to 2. So we have nd is equal to negative 2 omega. Therefore, this is a linear phase system. Thank you.
1, 2, go. Okay, so for example 3, sama je macam example 2, cuma we have to find the h omega for impulse response that given in this question. Okay, so kat sini ada 18 sampel, and this is the delayed symmetry signal. So first we have to find h naught n, the original equation, the input equation. Yang ni delay by 9. So after we have find h naught n, we find h naught omega by using symmetry properties macam previous example. So why we have to find h naught omega? Because in order to find h omega, we must know h naught omega. So after that, then we can find h omega by using time shifting properties or any properties gantung kat equation. So then find the phase of h omega to know whether it is a linear phase signal as system or not. So this is the output sketch of the question. That's all from us. Thank you.